This is on page 23 of your notes. So we're going to do a little tiny change because I think the language in this might get a little bit confusing. The sentence here. So here's the model of the Great Pyramid of Giza. I'm sorry that on yours, the picture is terrible. It's just like this big black rectangular blob. That's the way the photocopier decided to print it. So we made a model for a museum display. Now, it says the surface area of the triangular faces is 3,000 inches. I think to make that clear and to use our language, let's put a line through this. And we're going to just say the lateral area. One, because I want to remind you what lateral area is compared to surface area. The surface area of this pyramid would be all four triangles and the square bottom. A lateral area would just be the four triangles. This is a problem-solving question. And in a problem-solving question, sometimes it's helpful to draw pictures, to label what you know, and then try to figure out what you're trying to find. So the first thing I'm going to do is I'm going to draw square base, and straight up from the middle, pick a height, and draw my pyramid. With my height, I'm going to draw it with a green line here, right from the center all the way to the top. That is the height, which I'm going to use the letter H for height. This is what the question is asking for. And we're going to label everything that we know. It tells us that the side length of a square is 50 inches. And it tells us that the lateral area is 3,000 inches squared. So currently, with the three pieces of information that we know, there is no way to directly figure out what the height is. Okay? What we have to do is we have to sort of work our way forwards and backwards to be able to solve this. And this is typical in a problem-solving question. Okay? So here is the idea that we could do. We could say, well, what could we figure out? Okay? We'll sort of, I'll just put it down as the idea. Do you see that if you know the lateral area of all four triangles, you could find the area of one triangle? Then this is where you're going to easily make a mistake. Okay? If you know the area of one triangle, and you know the formula for the area of a triangle is base times height divided by 2, then you could find the height of that triangle. And the reason that it's a good idea, but the reason it's going to be a little bit tricky in this question is because if you find the height of the triangle, is that the same as the height of the pyramid? No. So if I draw the height of the triangle in blue, so there's a dotted line, or this is 90 degrees right there on one triangle, if I find the height of the triangle, it's actually the slant height of the pyramid. So I'm going to write, once we find the area of one triangle, we are next going to find the height of the triangle, and then in brackets, which is the slant height of the pyramid. So idea, I can find the area of one triangle. Great. If I had the area of one triangle, what could I do with that? Well, I know that area of a triangle is base times height divided by 2. Maybe I could find the height of that triangle. But I have to make sure that I realize that if I find the height of that triangle, it's the slant height of the pyramid. If I then use, right, and this is with the slant height, you can always make a triangle with the height and use a squared plus b squared equals c squared. So now we're getting into math questions that are quite involved, okay? You're probably used to a math question, seeing some stuff, and starting right away and doing some math. That is going to cause you problems because you won't have a vision of where you want to go. So in a more complicated question, first of all, you sort of have to break it down into, okay, what could I find? How would that help me? And come up with a plan. So we're going to do these 3 things. I'll number them 1, 2, and 3. We want to first find the area of one triangle. Since the lateral area is 3,000, we could divide that by 4. Go to our calculator. And we now know that the area of one of the triangles is 750 inches squared. Next, we're going to find the slant height. I'm going to switch my color to blue because blue is what I drew my slant height with. Okay? If you know the area of a triangle is base times height divided by 2, and maybe I'm going to change this temporarily to an S because it's actually my slant height and not my actual height. We have to be careful sometimes with variables. We labeled H already as the height of our whole pyramid, so it might get us confused if we also use H. Here, I know that the one triangle is 750. I can plug that in for area. I know that the base is 50. I want to find the slant height, and it's divided by 2. So I go to my calculator. 50 divided by 2 is 25. 750 divided by 25 is 30. So I've now determined that my slant height is 30. One thing that's also helpful as you're going along is you can do some labeling as you go along. So we just figured out that blue line that our slant height was 30. Maybe I even want to include units on here. As we're going. And then 3, find the height. And here I'll switch to green. Well, first I'm going to draw a triangle. I'm going to draw a black line there. I'm going to draw a green line because that was my height, and a blue line because that's my slant height. So what I'm doing right now is I took from my original diagram, I'm going to scroll up. In my original diagram, if I use the blue line, this dotted black line, and the height, I make a right angled triangle. So I use the same colors here, and I'm going to label everything that I know. How long is that black line? Close to 50. So if we look at our diagram, if all the sides are 50, does it make sense that going to the center would be half of that distance? So on this triangle, this would be 25. And what we're trying to find is h here. And so a squared plus b squared equals c squared. C squared is always the hypotenuse. Use your calculator. This will be 625. This is 900. We want to get the h squared by itself, so we would move that 625 over to the other side by subtracting, and we get that h squared is 275. Go to our calculator, square root of 275, 16.583. Inches, does it ask us to round to a certain thing? Determine the height of the model to the nearest tenth of an inch. So the last thing I always do is I reread my question to see what kind of rounding I would like. So again, a lot of these questions are quite involved because they won't be able to just do one thing to find your answer. So if we view everything that we did on this one, and they'll take some practice. That's interesting. First of all, we came up with the idea. That's important so that you're able to follow things through. Once I had the idea, each of the steps of the idea weren't too bad. But if you don't have the idea first, you're going to get lost in your steps. So I have the idea, I'm going to find the area of one triangle. I did that. Then I went back to my idea. What did I want to do next? Oh yeah, I wanted to find the height of the triangle, which is the slant height of the whole thing. So I found the height, area of base times height divided by 2 for a triangle, but now my height was actually the slant height, and I solved for my slant height. Then I used a squared plus b squared equals c squared to find the height. Some of the problem solving in this first unit is some of the hardest problem solving you'll do in grade 10. Like, I think that this is some of the biggest problem solving stuff that you'll do in all of grade 10, but it really sets you up nice as you go forward for grade 11 and grade 12. I'll make it big again. Anybody need the last part still? Or are we all good?